So I want to go back to this exact 1 second timer, and I want to introduce you to the simulator inside Atmel Studio, and you're going to need to know about this. So I've taken this code and I've literally just selected it and copied and pasted it straight into Atmel Studio. Okay, so there it is there. And what I've done is I've put a breakpoint here on the toggle LED. So what's going to happen now is I'm going to set up this program. I'll show you how it's set up. So I right click on the project. I don't right click on the solution. I right click on the project and go to properties. And I'm looking for the tool here, and I'm looking for the simulator. Don't worry about the other options I've got here, but you need to select simulator. When you've done that, just Control S, save it, and close it. So that's going to work now. And then what was going to happen is I'm going to compile and start debugging that. So I can use Alt F5. I can push this button on the toolbar here, or I can go to debug and start debugging and break. So the first thing that's going to do is it's going to compile my program, and it did it pretty quickly because there were no errors. And then it has started running the program, and it has started at main void, and it has stopped at the first command, which is to set the data direction register for D3. So I'm going to open up port D, and I'm just going to watch what happens as I step through this with F10. Okay, so I now set the data direction register for that bit. And now I'm going down to look at what I'm going to do with the timer counter register. So now you can see I've got this IO view open here. I've got a processor status view open here. To get these views, you're going to have to go to debug and then Windows, okay? And so there's the IO one and the processor status. Okay, so that's what we've got open. Sorry, I needed to point that out at the beginning. So once I'm looking at port D, I can see what's going to happen on port D. And then I want to have a look at timer 1. So timer 1, I'm just going to expand that. There's the prescaler there, timer 1, and if I click on this, there's all the bits inside the all the different registers and the bits inside them. You'll notice that some of these are 16-bit registers and others are 8-bit registers. And the bits that we can and cannot set are indicated for us. And the data sheet will tell you whether you should leave these bits alone or not, these blank ones, okay? What we're going to do is step 3, so I'm going to go F10, the next thing. Okay, so that what it did there was it set my waveform generation in timer counter compare register 1B. If I expand that, I can see that actually WGM1, there we go, I've set that bit, which is bit 3, okay? And there's bit 4. Cool. So what I'm going to do now is have a look down to the next one, which is timer counter compare register 1B, and I'm setting the clock source pins. So that's these 3 bits here, and you'll just see that after F10 that one of those is set, which is for our divide by 128. Our compare register 1A has got to be set to 62499. So I'm just going to click on that, and there we go. It's written in there now. I just make this a bit bigger. I can see the hex for 62499 is F423, and this is it stored here in the register. And then I'm going to set the timer interrupt mask. So that's where's timer interrupt mask? It's up here. So I can look at this and see which one of those bits. Okay, so I am setting output compare interrupt enable 1A. So that's now set. You'll notice that when you set a bit, it goes red like this. But after the next cycle of the microcontroller, it changes to blue. It's still set high, but it means that it didn't happen in the last cycle, okay? So we can now just have a look now. This set SEI, which is a little simple function, macro really, that sets a particular bit in the status register, and the status register is over here, so that's pin I. So if I push this F10, yeah, it now has disappeared into my while loop, and I've lost everything that I might want to look at, okay? So what it's doing now is it's actually counting. Before I went into the while loop, it had actually taken 39 cycles of the clock in the microcontroller to carry out those instructions, and which had taken 2.44 microseconds. So what I can do now is I can pause this using this pause control or break all up here. And it's just going to stop where it's at. You can see that actually we did have an interrupt bit set here. And so far, it's only counted 368 microseconds out of a full 16 million. Okay, so we're just going to let this run its course at the moment. It's going to take a while to get there. Now it's a simulator. It's running on a PC and a standalone program. It's pretty competent. Now, the reason I like this particular simulator is you can do some accurate timing on it. I haven't built those features into my own simulator. It's got other features that this lacks. For instance, the drag and drop and automatic configure of I/O, and later in the course we'll be talking about analog to digital conversion. So all those features are built into it. How are we getting on with this count? If I just pause this now, actually it's got to 14 million or 890 microseconds. So we're getting pretty close. What I'm expecting it to do is when it gets to 1 second for it to halt at this stage and break, okay? So we'll just let it continue for the moment, and there it trundles off. It shouldn't be too much longer. There we go. So now it's hit it, and it's hit it at 16,046 cycles. Now we started at about 42, but one of the interesting things you can do with this is you can set the cycle count back down to 0 and trigger it again and watch it go around and see how many exact cycles it takes to do this. What we'll have to do in the meantime is just wait, really. You can't see anything happening because it's running around in circles doing this counting, but it will take a little while. I guess some of the other things you might want to have a quick look at while you're here are having to look to see what's happening with the analog to digital. Oh no, you won't know about these registers yet. There's some CPU registers that we can look at. We don't get into those. The EEPROM, oh, there we go, it's toggled. I can stop waffling on about other things at the moment and tell you what's happening. So here we go, it's toggled the LED, and it took 15,999,998 cycles, which is 999,999.88 microseconds. Okay, so we're pretty close to 1 second. Okay, now why is there a discrepancy of 0.88 microseconds? Or in actual fact, why is there a discrepancy of 2 clock pulses in this timer? And I think that's probably to do with the fact that there's just a little interrupt jump that it's tried to anticipate or something. I'm not sure exactly, but this is going to give you a pretty good idea of exactly what 1 second looks like to the microcontroller. And at this stage, we could have a look at port B and see that it's clear. We could trigger this again and let it trundle along and see when it overflows whether it changes the bit or not. Now, I've noticed that there are a few little discrepancies around some of these in the timing. So we just wait for this to see if it does its actual setting of the bits. But yeah, anything else we want to have a look at while we're sitting here waiting? Really no, there's the other timer counters, the 8-bit 1, timer counter 0, and timer counter 2, which, oh, there we go, there it is. Now, if I push F10, hopefully it should, now it hasn't set the bit, it just doesn't quite always show up here as setting it, okay? So you just have to be a bit careful about that, but we can do our measurements, and there we go, we're setting at 32,000,003 cycles. Or 2.19 microseconds at this point in time. So that's just to give you a little brief introduction to the simulator inside Atmel Studio. It's got a number of different features, and you can look at different things, and we'll do a little bit more with this a bit later. So let's just stop that there, and we'll finish this for the next meeting.